the bag. Okay. There you
go. For those of you that brought your laptops, when you're done with your sandwiches, please open the gist that I sent a link to in the chat. This presentation is really code heavy, and it will be probably harder for you to understand what I'm saying if I'm just scrolling through code at my speed instead of you getting to scroll through your own speed. Unless you don't care about anything I'm saying, in which case don't do anything. I also added tests and a crappy assignment up to the repo. It's pushed to the master branch. And what this test does, I'll talk about it after we go through this example. But it provides one implementation of a library that's used to read and write values from a SQLite database. And then it provides a bunch of tests that hit that database using the old implementation, and then a set of tests that's very similar that use the new implementation whose types are mostly provided to you, but whose implementation is not provided to you. And your task is to basically uncomment out all the tests that have been commented out and make them pass. I put that together in about 30 minutes yesterday at the end of the day, so it's entirely possible that it will be maybe more challenging than it needs to be, or maybe even way less challenging than it ought to be. Okay. Hey, mic check. People in Westwood, let me hear you say yo.
Perfect.
Yay.
Can you do it together in unison? And in the key of A?
All right. Can you guys see my screen? That was a really weird noise you made.
I think it's unclear at this point.
I'll wait until you tell me that you can see my screen, because if you can't, this won't be very interesting for you. Okay. Okay. So a few caveats before I get into this. This presentation is a paraphrase ripoff of some person named Chris's wordier version of a general introduction to monad transformers. So if it looks similar, I admit freely that I ripped this person off. So don't accuse me of trying to be sneaky about it. What are we going to cover in this presentation? What monad transformers are, why you should care, and then we're going to implement a monad transformer in hopes of understanding how they work generally. I'm going to try to use common language to describe many of the things in this article or presentation or whatever, and that may be irritating to those of you that speak precisely about monad transformers. I ask that you step in to correct my wording only if it really makes sense and not because you're just a pedantic asshole.
That leaves me out.
Okay, so what is a monad transformer? It's a specialized version of a monad that allows it to be combined with other monads. Some examples of things that we're doing in the Haskell application today that involve monad transformers would be combining, let's say, the reader monad with the IO monad, which allows us to do things like pass configuration through our application, like a connection pool, from the point of starting up the application all the way down to the database access layer. We use the either T monad transformer in our HTTP request handling code. I believe that there is a similar abstraction in CJ Scala code, which allows you to write 4 comprehensions that short circuit if one of the steps being run in series fails. We have something similar in Haskell land. We're using the writer the writer monad, and I believe writer t, in our test code to capture arguments to the functions in our collaborator, in our collaborators. So we dependency inject a thing, and then we use the writer monad to capture any arguments that we send to the thing that we've dependency injected. And we make some assertions about like the state of that writer monad when we're done running our tests. Okay, so I was talking about combining monads. Like, why do you need transformers if you want to combine other monads? So take a look at the type of the bind member of the monad type class. Bind takes a monad and a function from A to MB and returns an MB. Note that the M isn't changing, right? So like if I bind, I don't know, like if I bind maybe and I give it a function that operates on the value that the maybe wraps in the event of the maybe being created with the just constructor, I can't combine that with a function that takes the value in the maybe to like IOB or something like that. The M has to stay the same. So I got some silly examples to demonstrate like the effect of this on your program. The program that I'm highlighting reads the contents of a file. And then if it is to put out a message to standard out that says the file is not empty, we actually have to pattern match on the constructor for the value that I've highlighted here. We can't use the maybe monad instance because this do block that I've highlighted is working within the IO monad. And this is a similar thing that I think y'all run into in Scala land with for comprehensions. The thingy that you're flat mapping, the interface that you're flat mapping on the right side of the arrow in the for comprehensions, I believe needs to be the same all the way through the for comprehension. Thus exhausting my understanding of the Scala programming language. So don't ask any more questions. If you wanted to attempt to use the maybe monad instance inside of this do block, which is otherwise relying on the IO monad, we'd get a compilation error because this right here, the M has changed. Like the M is maybe here and is IO right there. So we get a compilation error. And that's kind of a bummer because we want to combine things in our program. Like we want to combine configuration with IO, or we want to combine like logging through writer with IO, or this, that, and the other, either with IO, stuff like that. Okay, so what is the impact of this restriction? I wrote this little program that is a guessing game that's all about me. And in this guessing game, you're asked to guess the name of a city that I've lived in and the name of a band that I like. And I'll show you what that looks like. Stack exec, monad transformers example. I've lived in many cities. Can you guess one? You can't.
Los Angeles.
Nope. My program doesn't accept spaces. And what about sticks? Who doesn't like sticks? Okay, so in this program, the program does a few things. I'll just go from top to bottom. But so if you guess correctly, you get a message at the end. If you guess incorrectly in the first step, Hades, I haven't lived there. Guess one, Metallica. So I have lived in Hades, but I don't like Metallica. So the program's short-circuited before outputting this thing here because my second guess was wrong. So let's just get into the code and see what it looks like without monad transformers. What we're going to do is I'm going to give a straw man, and for motivation being that I want to show how monad transformers can be used to clean up some really crappy code. We're going to implement a monad transformer, then we're going to use it, and I'm going to show you what the code looks like afterwards. So prompt for guess is going to ask you to enter in some input, and then it's going to validate that input is just alphanumeric characters. And if you input something that is not alphanumeric, then we're going to fail out of our computation or we're going to fail out of our program with an invalid input. We're going to output something to the screen. Let me ensure that my program actually does that. Okay, cool. So notice I entered derp alert, and you don't get asked to guess a band. We short circuit out of this thing. This is a thing that you do in your programs. So we validate that the input is an alphanumeric, or rather contains only alphanumeric characters, and then we consult some oracle. We consult a file on disk, and we compare your input with all of the strings in that file. And if there's a match, then we return IO right, guess, way to go. Otherwise, we return left, signaling error. So the thing to notice here is prompt for guess has type IO either game error string. Validate input is pure. It just uses either. Check guess IO either game error string. These types are slightly different. Either game error string to IO. And that presents some challenges when we go to combine these things into our game. So this is dumb. Prompt for guess. Well, first of all, note that this entire game function operates in IO. So put string line is going to use IO, going to write standard out. Prompt for guess is going to get stuff from standard in, but we're going to get back values of type either game error string when we bind these IO computations. And then in order to short circuit, we got to do this lame pattern matching thing. We can clean that up by using the either function, but the cleanliness is not as, or rather, it doesn't look as different as you might think. I'm not going to show that, but the thing I'm trying to point out is that I can't use the monad. I can't use the monad instance of either inside of this IO computation without introducing something else or writing this code in a very different way. But notice we prompt for guess. If the validation function said that the thing you inputted was not alphanumeric, then we bomb out. Otherwise, we keep going. We check to see if that guess was valid. If not, we bomb out. So there's all this check, proceed if we didn't fail, else exit the program. And the thing I wanted to point out is that we're pattern matching on the constructor of either all the way down. You're aware of the either instance of monad, or rather the monad instance for either. If you have a value of type either EA and you bind it, if the value was created with the right constructor, then K is applied to the value of type A. Otherwise, we don't do anything with the E. But we can't use it because we're in IO, and that's a bummer. Okay, so transformers. I was talking about combining monads. Transformers allow us to add the functionality of one monad to another monad, producing a new monad. And that new monad has all the functionality of both or the number of monads that you've combined. And that allows your bind function to preserve M all the way through. M never changes. M is a monad that has all the functionality of all these things. Okay, so to illustrate the point, we're going to roll our own monad transformer. In our program, in a lot of places, we see some type that looks like this, where we've got this IO computation that produces, when bound, a value of type either EA. So we're going to create a new type called either IO. Either IO has got a constructor that allows you to go from this type to your either IO type. And let's see, here we go. So F is a value of type blah, blah, blah. You pass that value to your either IO constructor, and then you get back an either IO EA. The field here allows us to go the other direction. So if you have a value of type either IO, and you apply run either IO to that value, you get back your original value of that original type. So from here on out, I'm going to talk about going from IO either EA to either IO EA as wrapping, and the other way is unwrapping. Okay, so in order for us to be able to use this new supermonad as if it were a monad, we have to instantiate all of the type classes that allow us to create a monad, which includes functor and applicative. And I'm going to provide an implementation here and explain how this works. But it's important to remember that either IO EA is really the same as IO paren either EA, which is to say an IO computation that when you run it gives you back an either value. So the functor instance here says when you fmap a function f over a value of type either IO EA, what we do is we run the underlying IO computation, which gives us either left E or right A. If the resultant value is been created using this left constructor, then we leave it alone and we just give you back IO left E. Otherwise, we apply F to the A inside of that right. This is not a real Haskell type, but it might help you sort of envision like what's going on here. The applicative instance, I have no idea what that does. I stole this example from that other dude's blog post. If I sat here and scrutinized it, I could probably figure it out. I know how to use it, but not exactly how to explain that f app x. And I'm not going to try to. The monad instance is the most interesting, I think. So now we've got this value of type either IO EA, which is this super monad that combines the IO monad, which allows us to like interact with the outside world, and the either monad, which allows us to short circuit a series of computations based on a constructor. Now we've combined them, so what does it actually look like when we want to bind it, like when we're in do notation or whatever? And what does that bind actually mean? When you bind a value of type either IO EA, what's happening here is that we run the underlying IO action. If that action produced left E, then we leave the left E alone. Otherwise, we apply our function f to that A, and that function f must produce a new value of type either IO EA, which allows you to, which satisfies the monad type class. And so why would we ever do that? Yeah, what's up?
What is that lowercase either function?
The lowercase either function, when given a value of either EA, so the first argument is a function to, do you know what it does? Or do you actually want me to explain it? I can explain
I don't know off the top of my head.
Oh, okay. So
Like maybe.
either, have you used the maybe function before? Okay, so it is spiritually similar to that. The either function, the first argument is a function to apply to the E in an either EA. If the either EA was created with constructor left, otherwise a function to apply to the right A if the either was created with the constructor right. And so what happens here, this run either IO gives us a value of type IO either EA, and when you bind it, the argument to the little lambda here that's implicit is either EA, which is then passed down to this either function. I could have introduced a lambda here to make it a little more legible, and I encourage you in the homework assignment to be as verbose as possible when implementing your own monad transformer before you try to go all point free. The reason the point free is here is because I stole it from someone else's blog post, and I had to go back and write this all down, working out the types in order to explain it to you today. I didn't come up with this myself. I'm not that smart. Okay, so an example of how you might use this new supermonad that combines either and IO. I've got this function bad that writes to the console bad and then returns left constructor bummer, and then good prints good, and then right constructor 100. And what that looks like in my program is very similar to what we have in this HTTP request handling code that I keep referring to in Scala. And this is actually pretty similar to what we're doing in the Haskell application as well. We got a function that returns either IO. We bind it, and so we execute all of this stuff if we got back the right constructor. So we happily proceed down to the next bind. We bind it. but we hit left, which causes the rest of the computation to short circuit. So we don't actually run that stuff right there. We short circuit out. And the important thing to note here is that we're able to combine the short circuiting capabilities of either with the reading and writing writing to standard out, interacting with the outside world of the I/O monad. So we run it, good, bad, left, bummer, and you don't see good that second time. Okay, so conveniently, these functions that I wrote are all of the same type, either IO string int, which is really IO either string int. What happens if you've got what happens if you want to use functions in this program that are of type IO something, or maybe functions that are of type either something? That type, either string int, is not the same as either IO string int, and IO int is obviously not the type of either IO string int. So we need to write some functions that allow us to bring those functions into our program. And we don't want those functions to have to know about how we've specifically combined the monads. We want them to be general purpose, usable in any monad or any monad transformer stack, not necessarily just ours. So we can do that with our either IO monad, specifically using the lift function. This is not generalized to every single monad. Specifically, this one is built to take a function that operates in I/O and bring it up into this either I/O monad. So what this thing does, you give it a value of type IOA, and we fmap the write constructor over that value. And what that produces is an I/O computation that, when run, will always produce write wrapping the value of the original I/O computation. That allows us to mix functions that operate in I/O with functions that operate in either I/O alongside each other, without this put string line function having to know about the way that we've combined our effects. And that sounds kind of handy. Right, these general purpose functions with I/O, they don't have to know about how they're being used.
Can you scroll back up to where you don't use the lift and compare the functions?
Yes. Are you talking here or someplace else?
Well, example 3, you don't use the lift, but it was kind of, you didn't really mention it, but the either IO colon and the $do encapsulated underneath, right? So.
Yes. Okay, I got you. Right, because this is the IO monad right here.
Right.
Yeah, so either IO, that constructor takes a value of type IO either EA, and in order to easily create one of those things, this do block right here produces one of those dealy bobs. And then that value is used to construct this value of type either IO string int. I'm not really sure how to explain what I've highlighted on the screen right there, but that do block is in the IO monad, and the value produced is a value of type either IO string int. Do you have anything more to say about it than that?
I just want to see if you can compare it, because it's kind of implicitly just
cranked through it.
Yeah.
Yeah. Well, the short answer is no. I don't know how to compare it. Do you know how to compare it?
You could just like show this is what it looks like on this side, and these are the types. This is like the next transformation step, right?
I don't know what you're getting at. I must admit. Let me burn through this, and then we'll come back to it. Is that fair?
Sure.
Okay. Okay. So that's it. We just implemented either IO. So either IO is this combination of the IO monad and the either monad. I did that for a couple of reasons. One, that other dude already came up with most of the examples, and so I could just steal everything from them. The program that I wrote earlier already was using IO either EA, so it seemed like a good candidate. And for me, programming with this concrete combination of types first helps me understand all of those type class instances before I try to go generalizing things. But as it turns out, that either IO monad or that either IO type that we created is really similar to either T, which is a general purpose monad transformer that allows you to add either capability to any other monad. So what we're going to do in this next little section is we're going to compare the types for all of this stuff that we use to create either IO with their equivalents for either T. Remember, either IO is a specific combination of either and IO. Either T is either monad plus any other monad. Okay, so first let's look at the data constructor. The data constructor of either T takes one more parameter, one more type variable, M, which is representing that other monad that you're wrapping. Down here, I didn't need it because I chose M to be IO. Similarly, the run either T, it used to have IO on the outside, now it's got M on the outside. The functor instance, oh, I forgot to copy paste it there. The functor instance hasn't had to change much at all either. I used to have either IOE here, and I had no functor M constraint, and the M type variable did not exist. But the thing that changed down here in the guts of this function, aside from this either T constructor, is run either IO instead of run either T. So I really haven't had to change that much, and the process is still the same. For any monad that I choose to add either like functionality to, F mapping over it means run the underlying computation and then F map that thing. Or rather, sorry, reverse order. F map the outer either, and if we didn't bomb out, then do the inner one. Is that true? No, the other way around. I think I was right the first time.
You were right the first time.
Okay, so applicative functor instance, also not different really. Notice we've got the applicative M type class constraint on that type variable that represents the monad, and the transformation is really straightforward. Same thing with the monad instance. Lift also becomes, my copy and pasted either T instead of either IO, but lift now is generalized to lift a function in any underlying monad into the either T monad. So with all that said, I know I've gone real fast, but I'll show you what the original program looks like compared to the new program. Now that we've combined into our new monad the either functionality with the IO functionality. So when we used to prompt for guess, and that thing could fail because of validation purposes, which was all of that, now we have that. And if I were to move the either T type into prompt for guess, which right now is just IO either string error string, I could have even eliminated this constructor. But I'm reusing the function from the original example, which introduces this little guy right here. But we do this IO stuff, returning an either. If we fail to validate, then none of this stuff gets run. But just take a look at like an example of like what you can do when you combine these two effects, IO and either. And as it turns out, for those of you writing Scala, there's a cool blog post I read about monad transformers in Scala as well that shows a way that you can combine values of types that have the flat map method in the same for comprehension. Or for expression, maybe they call it. But yeah, we use this stuff all the time in the existing application. There are a variety of topics that we could go into after this. There are libraries that help you out when combining monad transformers called MTL and transformers. But I think maybe we'll leave that until after this assignment, which just forces you to implement a single monad transformer yourself without having to try to figure out all these external packages. That's it. That's all I have to say about that.
Nice.
So I only have a vaguely tenuous grasp on this
Sure.
whole concept, but the existence of something like either T lead me to wonder if is there some kind of like type class for monads?
Monad transformers.
Transformers for other.
Oh, let's take a look. Transformers Haskell package.
Oh, that's what that's like. Okay.
Monad.trans.class. I'm pretty sure the answer to your question is yes. I didn't get into it because I personally it helped me to first implement one
Yeah.
without the indirection. But you're totally right. Like this concept has been abstracted over. Let's take a look at what the members are.
It's just lift.
It's just lift, he says. It's just lift.
Monad constraint.
With a monad constraint on them.
That's cool.
Nope, I have no idea what's going on.
Yeah, I mean, I must be honest with you. Like, I learned to, personally, like, I learned to cobble examples together before I really understood how the sort of types worked out. And I think, and that's okay. Like, you can certainly write programs that use monad transformers and be effective in this programming language without fully understanding, like, the machinery of what's going on. So if you go through the assignment and you get the thing to type check and the tests all pass, but you still don't really get it, I wouldn't be bumming.
I still gotta figure out regular monads. So.
Yeah, right, exactly. So yeah, but yeah, there is a type class that abstracts over this notion of a monad transformer.
They're not burritos. I read the burrito text and it was complete nonsense.
The burrito thing?
Yeah.
Did they use like verbs like wrapping and unwrapping?
Well, the metaphor was idiotic. It's.
I think that's the whole point, to be honest. That the metaphor is idiotic.
It was written as a parody.
Yeah.
Right.
Yeah.
So.
The original was written as written. It was making fun of all the other monad analogies, for comparing them to other things.
The best analogy I've come across so far is a monad's a type of box, and that it actually kind of helped
A
me.
round box made of flour.
Yeah.
Or corn, come on, man.
Nonsense.
Yes. In fact, you want to bring up that post with the like pretty pictures of all the
Oh yeah,
Yeah.
Haskell type classes illustrated maybe.
That is what?
Abit.io.
Somebody,
yeah,
yeah,
that's-
Oh, how do I find it?
Just go to abit.io, I think is what you're talking about.
8 or A?
Abit.
A-bit.
ADIT.
ADIT. sorry.
DIT.io.
Yeah.
Oops.
A, B.
That is pretty good.
Yeah, there you go.
And then,
No, what's
I'm
the
just
other
looking
one?
at the monads and pictures.
Yep.
Yeah.
This is a beautiful blog post.
Oh yeah, that's the one.
Yeah.
Yeah, this is the first monad thing I read that made sense.
Who's that word content? No, it's nice that it kind of shows you the difference between functors,
Yeah.
applicatives, and monads, all using the same analogy.
Now if I just read it 30 more times over the next year or so, maybe it'll.
I'd like to walk you all through very briefly the homework assignment that I put together, so that like you understand what I'm asking you to do, because if you go to the CIS 194 GitHub landing screen, there's nothing here in the assignment section. So let's look at the codes. I just merged this thing into master like a wee moment ago. So there's now a week 11 spec. If you run the test suite, you'll see it. Okay, so what I did was I wrote a little database library that, and let me show the library as well, and let me change the font so you can actually see it. It's a strange noise you just made, Hal.
Yeah. Sorry.
I don't have to apologize, I'm just saying.
Probably went out over the. You still recording?
I'm still recording, yeah. Are you kidding me? I'm not letting any tasty nuggets of knowledge like escape this recording. Okay, so I'm going to show you the reference implementation. So I wrote using a database library that I'm familiar with, a series of functions that allow you to like put stuff in a database and get stuff out of a database. Pretty straightforward. I wrote some tests over here in this reference lifecycle section that creates the database schema, gets some users out, jams some users in, gets user by ID, just basically exercises these functions. And it's not super sexy or anything like that. But this implementation has one thing about it that I think is really dumb. and that's that every time you call one of the functions, get user by ID, get users or whatever, we actually create a new connection to the database, and then after getting those rows out, we close the database connection. And I thought that maybe a fun alternative would be to create a database connection before running the tests, load that database connection into the reader monad, and then run all of these I/O operations in an environment in which they can use a connection that's already been opened for them. So all these tests that I have commented out assume this new implementation that uses the reader T monad plus I/O. So if we're looking here at this reference file, and we hit back, and then we go to assignment, we've got functions with the same name, only the types have changed slightly. And I was nice, and I commented out the implementation of setupdb that actually uses reader T. But what this assignment is asking you to do is to re-implement the reference database library using reader T, which is a monad transformer that is going to wrap I/O. You're also going to have to implement reader T yourself, which means you're going to have to go figure out how to implement reader. But I think it's a pretty I don't think it's as far as these things go it's going to give you a ton of challenges. So a couple things. Reader T, we're using that in our program today to pass configuration information around. You might pass a connection pool around or something like that. In this case, just use a connection, and that's codified in the type. And then you actually get to read and write from a database, which is a thing that people do at jobs sometimes. So that's kind of cool. So that's it. If you get stuck, reach out to the room. If you just can't figure out how to implement reader T, I made a note in here. If you can figure out how to install the transformers package on your branch and use the reader T that they've created, this assignment will be really, really, really easy. You can do it if you just can't figure out how to create your own reader T. But
So they have the source in there somewhere.
yeah, you could just go look at the source. I recommend that you don't do that unless you just get really sad at trying to do it yourself. And that's it. Good luck. Okay, Joe, you had a thing that you mentioned in the prez
Right.
that I didn't grok,
Okay.
but I'd like to grok it.
Well, it should be really quick.
Okay.
I just wish you compared the examples of the previous one before you made it into the next step of the transformer.
Which you did later in the
Yeah.
presentation.
You said either I/O, and then you said either T. And you're comparing. Well, you did it later. You compared the implementation.
You want to see them side by side.
Yeah.
Oh, and hold on.
You start doing that later. But you didn't do it initially.
Oh, okay. I got you. I think I got you. Which one would you have expected to see?
Between example 3 and example 4. That was
Okay.
the first one. Or that
Oh,
was-
before I introduced lift.
Yeah.
Ah, okay. I got you. Okay. Yep, I got you. You would have maybe before introducing lift, introduced the either IO constructor here
Well,
and returned that into.
order it. Just
No, he just wants to see example 4 again, right next to example 3.
Oh,
Or bring example 3 down again.
Oh.
So you can
Okay.
see what the transition was.
I'm smelling what you're cooking.
Yeah.
Okay, sweet. Hey, phone people, you got anything to say about things? Yeah, right on. Okay. That's all I got. We could switch gears and talk about the homework, but I'm looking at the homework and it doesn't look like anyone that's name is not Alexis did it. So maybe we don't talk about it right now. Cool.
Silent cow.
Okay.
Anybody attempt the homework?
Yes, I just
Yes.
attempted it, except for number 5.
At great length, and I'm stuck,
You're stuck.
quite stuck.
What are you stuck on?
The first problem.
The first word.
There.
the first
Hey,
question.
phone people, I think we're just going to hang out eat sandwiches and maybe talk about the homework. Do you want to stay involved in that, or shall I end the meeting? Okay. Okay. All right. See you later.
Bye.
QuickTime Player. How do I? Yeah. There we go.